In this section, we're going to tie everything together using different methods for finding zeros of a polynomial. So this is going to be some things that you've already learned how to do up to this point and a few new things. So first, let's talk about the number of zeros of a polynomial. Back in section 3.3, we said that a polynomial has at most n x-intercepts, where n is your degree of your polynomial. Well, now if we're talking about zeros, not just x-intercepts, the number of zeros is equal to the degree of the polynomial. So now we're going to be talking about all the real zeros and if there's any imaginary zeros. Remember, if you have an imaginary zero, it doesn't show up on the graph, so it doesn't show as an x-intercept. But a polynomial will always have the same number of zeros as the degree of the polynomial. So if I have a fifth degree polynomial, I'm going to have 5 zeros. So just keep that in mind as you're finding zeros. We're going to start by a polynomial where you can factor out the greatest common factor. If you look at this polynomial, notice that every term has an x, so there's no constant by itself. That means there's a greatest common factor of x squared that I can pull out of the entire function. So when I pull out an x squared or factor out an x squared, that's going to leave me with x to the fourth minus 3x squared plus 2. So I've factored out the greatest common factor of x squared, and then I can factor that fourth degree polynomial just like if it was a quadratic, but instead of having x and x, I'm going to have x squared and x squared to get that x to the fourth. And I'm also, if I have a minus then a plus, I'm going to have two negatives, and the factors of 2 are 2 and 1. So if you FOILed that back together, first would give me the x to the fourth, outside would give me negative 1x squared, inside would give me negative 2x squared, and then last would give me a positive 2. And so these would combine to give you the negative 3x squared. So that gives me back that original function, x to the fourth minus 3x squared plus 2. Now at this point, we're going to set each one equal to 0. So I'm going to have x squared equals 0. I'm going to have x squared minus 2 equals 0. And I'm going to have x squared minus 1 equals 0. Now on the first one where I have just x squared equals 0, when you square root both sides, you get x equals technically plus or minus 0, but that's just 0. Here, when I add 2 to both sides, I get x squared equals 2. And then when you square root both sides, you get x equals plus or minus. And then you're going to leave it as the square root of 2 because it's not a perfect square. And then the same thing with the x squared minus 1. I'm going to add 1 to both sides and then square root both sides, and that leaves me with x equals plus or minus 1. Remember, when you square root both sides, you always get the positive and negative of that answer. So my zeros are 0, positive square root of 2, negative square root of 2, positive 1, and negative 1. Now notice earlier I said you have the same amount of zeros as the degree, so I should have 6 answers, but because positive and negative 0 are the same number, that's a repeated 0. So it's only going to show up once, but it's going to touch on the graph at 0 because it's a repeated 0. let's look at the next one now. This one, finding zeros, we just have a quadratic that we can try to factor first. And that is actually going to factor into -3 and -3. That will give me the -6 in the middle and a +9 at the end. So that is actually, if you set them both equal to 0, you're going to end up with x equals 3. So again, we have a repeated 0. So the same linear factor multiplied by itself gives us our original function. So even though there's one answer for the quadratic, that's a repeated 0, so there's actually 2 zeros. Okay, the next example, again, we have a common factor of x because our last term has an x in it too. So I'm going to start by pulling out x, which will leave me x squared plus 4. And then I'm going to set each of those equal to 0. So I've got x equals 0. And then I've got x squared plus 4 equals 0. And you're going to extract the square. I'm going to subtract 4 from both sides. And then square root both sides. So that gives me x equals plus or minus. The square root of -4 is going to give you an imaginary number. So you're going to end up with 2i. So here you do end up with 3 answers for a third degree of 0, -2i, and +2i. This next example, we've got x to the 4th minus 1. This is a difference of 2 squares. Now I know that because there's no x term in the middle. It's just got a perfect square to begin with and a perfect square to end with. That is always going to factor into conjugates of each other. So here, if I factor x to the 4th minus 1, I've got positive and negative. And then I'm going to take the square root of the first one, which is just going to be x squared. Or ask yourself what times itself equals x to the 4th. So I've got an x squared and an x squared. And then the square root of 1 is 1. So that factors into x squared plus 1 times its conjugate, x squared minus 1. And again, if you want to check, if you FOIL that, I get x to the 4th minus 1x squared plus 1x squared minus 1. And your middle terms will cancel each other out. And that's always going to happen when you multiply by a conjugate. The middle two terms will be the opposite of each other and end up canceling out. So here I've got x squared plus 1 equals 0 and x squared minus 1 equals 0. So here I'm going to subtract 1 from both sides and square root it. So that leaves me with x equals plus or minus the square root of -1 is going to give me 1i, or just I. And then over here I've got x squared plus 1 equals 1. And when you square root both sides, you end up with x equals plus or minus 1. So my solutions, or my zeros, are -i, I, -1, and 1. So those are my 4 zeros of the function.